typical reverse osmosis water system consists of 3 filters for removing particulates and other contaminants, a booster pump, a reverse osmosis membrane, a pressure tank, and an outlet faucet. Tap water, okay, in this particular case, goes through a sediment filter. The sediment filter is a 5 microns filter, which will remove most of any kind of solids in the water itself. Okay, the more solids you remove, the better off you are in prolonging the longevity of your other filters downstream, including the RO element. Okay. This particular one has a low pressure switch in because we have a booster pump. So when it detects low pressure, it'll shut the pump off. Okay. The next filter in line, okay, is a GAC filter. Okay, GAC stands for granular activated charcoal. Okay, and that particular filter removes the large molecular elements in the carbon itself. And such things as gasoline, for example, okay, is a large element. Ethyl acetate, for example, is another one. Once it leaves that particular filter, it goes to a CTO block carbon filter, which CTO stands for chlorine, taste, and odor. That, of course, both of these elements are 5 micron as well, so you have some really pretty good filtration. The booster pump is located next upstream. Okay, the idea of the booster pump is to get 100 psi, pounds per square inch, into the membrane, which is the most efficient operating pressure for the membrane. Remember, the membrane itself, the reverse osmosis membrane, is 0.0001 microns. It's a very tiny hole, so the more pressure you have, the better off you are. Okay. From this particular membrane, the what we call the brine, which is the water that has not been forced through the element, exits to a drain. Any particular drain over there. 80% of the water, okay, is passed through as purified water. In that case, runs through a high pressure switch, which is another safety feature, such as the low pressure switch for the pump itself. In the case of the system we are using at this demonstration site, we pump up a pressure tank, which is about a 2.5 gallon tank, okay, and it's in parallel with the outlet faucet. So the system will automatically fill up this container with water. The air bladder will compress up to match the pressure on the pump itself. When you open up the faucet, this water will come out. As it drops low enough, the automatic control switches will take place and activate the pump again, refilling the bladder. The three filters, okay, and primarily the second and third filter, okay, the major contaminants that are removed in here, okay, are such things as arsenic, barium, cadmium, chromium, copper, cysts, turbidity, fluoride, lead, radium, and selenium. In addition, things such as diesel fuel, gasoline, citric acid, benzene, butyl alcohol, any soap, any solvents, siphonnated oil. These are all removed in various percentages. For example, okay, copper, okay, is a 99% removal. Okay, arsenic is 98.7 removal. And that's a function of the filtration itself, okay, plus the membrane itself. Because we are using a city water tap, the life of these filters, the 3 main filters, okay, is extended. Okay, if we were using well water or rainwater, the usage, these filter life would be reduced. In any case, this particular system produces about 100 gallons a day. That would be 700 a week, which is sufficient for a moderate-sized system. You would be replacing these filters once a year. Membrane you would replace once every 2 years.